Okay, so on the review, 5.1 to 5.4, we're on problem number 3, and we're doing part C. If you're confused about A and B and you haven't watched the videos yet, please go back. Those are both done on one video on the multimedia page. As for C, I want you to look at every single problem that you see, every single number that you see in each of these fractions, and tell me if you see 4 and 8 on the same power tree down here. Yes, 4 is 2 squared, and 8 is 2 cubed. So 4 and 8 can be expressed with the same base to a power. So what I want you to do is I want you to go up here, and I want you to rewrite the 4 as 2 squared, and the 8 as 2 cubed. And we're going to hope that their partners in crime in each of those fractions will have the same exponent on them. And I think they will. Where do you see both 25 and 125? 5 squared and 5 to the third. So let's rewrite both of them as 5 squared and 5 cubed. These problems only tend to work out when the numbers are set up perfectly. And eventually, when we get to the second half of Unit 5, we're going to see a different way of doing these. We're going to get to the answer using logarithms, all right? But I'm kind of building that up with you. I'm building it up. I keep mentioning logarithms. It's coming in the future. We're going to see it. So it's like when they keep previewing a movie over and over again, and you're like, I can't wait to see it. That's what I'm trying to do, okay? You can wait? Okay. Maybe. So the next thing we're going to do is we're going to say, if you have a fraction, and this goes back to one of those old rules, let me do it over here on a separate page. You had a to the n over b to the n. How can you rewrite that? A over b, both to the n, right? Remember, all these rules work in both directions. We often used it this way. If you had a fraction to a power, then they both get that power. Well, now I'm doing it the other way. I'm saying you have the top and bottom to the same power. So here's what we can do. I can write 2/5 and take that 2 that they share and put it up there with the x. Yes, but I went to the next step in my head, which would have been multiplying the 2 and the x. Because when you have a power to a power, you can multiply the exponent. The student asked if, wouldn't you have parentheses there? And it would have looked like this. It would have been 2/5 squared to the x. And what I was saying is, what can we do with the 2 and the x? Multiply them, and we would have ended up right there. Ready? Now, on the other side of the equation, you don't have 2/5. What do you have? 5/2 cubed. I'm going to bring the cube out. I just wish there was a way to turn 5/2 into 2/5. I can do it as long as I make its exponent negative. Watch. On the left side, I'm not going to touch it. Leave it alone. On the right side, this fraction would be flipped if its exponent was -3. Again, the rules work in both directions. Normally, you're given a negative exponent, and that makes you flip the base. If you want to flip the base, give it a negative exponent. You're doing it the other way. Now, we go to another rule that I'll show you on another page, and that's this. If you have a base to a power and the same base to a power, you know what you could say about their powers? They're the same. That's what we have right here. Let me highlight it in blue. this base is to the 2x. The same base is to the negative 3. So what's true about 2x and negative 3? They're equal. And if 2x equals negative 3, x must be negative 1.5. You divide both sides by 2, and you get negative 1.5. If you'd like, check your work. Type in parentheses 4 over 25 to the negative 1.5. 4/25. 4 over 25. 25 to the negative 1.5. It gives me 15.625. I can change that to a fraction by going math, fraction, enter, 125/8. Is that what we wanted?